Our guest house speaker, Dr. Sundari ma'am, to deliver online lecture on behalf of Institute of Engineers, India, Tamil Nadu State Center. So the Dr. Sundari ma'am is very well known to me. Frequently, I visited Sathyabama Institute. Ma'am interacted more in Institute of Engineers, especially the association activities will be more. On this occasion, will once again I congratulate Dr. Sundari ma'am. Previously, ma'am was in Dean Administration. From today onwards, she took new charge as a Registrar Sathyabama University.
Thank you, sir. Thank you.
Congratulations, ma'am. Congratulations.
Thank you, sir. Thank you. Thank you.
So the today topic is 5G technology. This is a right topic and right time because nowadays everybody is they are moving with they will need expecting speed. Even the net and the entire thing they will expect this speed. So with the help of this the 5G technology, we are fielding pioneer in this technology field all over India, especially the space and other things. We are very pioneer. So the today topics will be fully deals with that 5G technology, that to architect applications and future scope. This is a right topic, and also ma'am cover very wide area for touch upon all three areas. I hope the today lecture will be most beneficial to our committee members, faculty members, and students. Now I invite our guest speaker, Dr. Sundari ma'am, Registrar Sathyabama University, to hand out the session. So now the session's forum is to you, ma'am.
Thank you, sir, for your brief introduction. I'm really happy to be a part of this guest lecture series. My special thanks to IEA Tamil Nadu State Center for giving me this opportunity to share my thoughts with you all. And at this juncture, I am also thanking Dr. Karthikeyan, the chairman of IEA Kanjipuram local chapter, for facilitating this. So let's now begin this topic on 5G technology. I would like to share the screen, sir.
Yes, ma'am. Yes.
Okay. Whether full screen is visible? Whether full screen is visible?
No, not visible.
Yes, ma'am. Now it's now
okay. My screen is shared, sir?
Yes, ma'am. Perfect, ma'am.
Okay. Right. Okay. So good evening, participants. So today's topic is all about 5G technology, architecture, applications, and the future scope. Whether my voice is audible?
Yes, ma'am. Clearly it's audible.
Right. Okay. So first we begin with evaluation of mobile communication. Today, let's take a quick journey through the evaluation of mobile communication, a transformation that has not only changed the technology, but also the way we live, we learn, and connect with the world. So to begin with 1G, the first generation of mobile communication, which was introduced in 1980s, this was purely a voice-based communication using analog signals. People could make calls, but the quality was poor, the security was minimal, and there were no additional services. But it was revolutionary that time because first time the communication has become wireless. Then came 2G, which has marked the shift from analog to digital communication. And this generation has introduced SMS, short message service, which allows people to send text messages, and the call became clearer and more secure. And then people started using mobile phones. Communication was no longer just talking, but it included messaging as well. Then we have entered into the era of 3G, which has brought mobile internet and multimedia capabilities. People could browse websites, send emails, make video call, as well share images and videos. So this generation, third generation, has laid the foundation for smartphone revolution, turning the mobile phones into powerful personal device rather than just a communication tool. After that, 4G has transformed the digital experience completely. So it has enabled high-speed data, high definition video streaming, online gaming, and other mobile applications. So the platforms like video streaming services, digital payment, and social media that has flourished because of 4G speed and reliability. So it connected not just people, but also the lifestyles. And today we are now in the era of 5G, the fifth generation of mobile communication. So 5G is not just an upgrade in speed, it's a technological shift that is designed to connect everything. So I can tell you that 1G connected voices, 2G connected people, 3G connected information, 4G connected lifestyle, and 5G is connecting the intelligent world. So the journey of mobile communication shows how technology evolves to meet the human needs, right from the simple conversation to building a fully connected digital ecosystem. So this is all about the evaluation of mobile communication. And now we are moving to what are the key performance targets of 5G. I have changed the slide, whether the participants are able to see the change in the slide.
Yes, ma'am.
Yes, ma'am.
Yes.
Okay. So now we understood the evaluation of mobile communication. So let's now look at what truly defines 5G. What is 5G all about? People are talking about it. It is basically giving you three main services, which is being standardized by third generation partnership project. We call it a 3GPP. It's actually a global body which is responsible for defining the mobile communication standards. And these three categories completely address the different needs of our digital world. First one is EMBB. It is called Enhanced Mobile Broadband. Mainly, it focuses on extremely high data speed up to 10 to 20 gigabits per second. So this is actually 100 times faster than the 4G speed. With this EMBB service, we, the users, can experience ultra high definition and 8K video streaming. If I say 8K video streaming, you just imagine it is 16 times faster than the full HD. And then seamless video conferencing and immersive AR and VR high-speed connectivity. Where do we require mainly high-speed connectivity? In crowded places like stadium, airports, cities. So all in simple terms, I can say this enhanced mobile broadband we use this in everyday digital experience because of its high speed. And the second one is URLLC, ultra reliable low latency communication. This is actually the second service category. This is not focusing only on speed, but also how immediately it can respond. That is what we call it as low latency or low delay. So the latency can be as low as 1 millisecond and the reliability is great, 99.999%, often which we call it as 5 nines reliability. So this level of performance is really essential. Where do we require this? For mission critical applications. I mean mission critical applications. What I mean here is where the delay is no more acceptable. For example, where we do remote surgery or in autonomous vehicle, connected vehicle, where immediately the decision has to be taken, otherwise it will end up in accidents. So where industrial automation and smart factories and real-time control system, even a tiny delay is highly dangerous. In this, 5G ensures communication happens almost in real time. And the third one is MMTC, massive machine type communication. It's a third category of service, which is designed for the world of IoT, Internet of Things. So 5G can support up to 1 million connected devices per square kilometer. And so these devices include, what are those devices? When I say devices are connected, like the mobile phones, whatever we use, the smart sensors, wearables, environmental monitoring system, or agricultural and industrial IoT networks. So all these devices are being connected. Millions of devices can be connected because of the service that's been provided by 5G. So this MMTC is optimized for very low power consumption and long battery life. That means devices can last for years and effective communication between machines rather than humans. So I can summarize in this way. So it is a powerful, 5G is very powerful because not only for one network, it is able to serve for 3 different networks where you need high speed experience, where you need real critical communication, where you really need massive connectivity for smart devices. So together I can say these are the 3 pillars. This enhanced mobile broadband, ultra reliable low latency, and this massive machine type communication. All these are called 3 pillars, which really makes 5G the foundation for next generation digital transformation. And now we move with the mobile network architecture. We have seen how it has evolved, the evaluation. And now we are going to discuss on the evaluation of mobile network architecture. 2G, 3G, 4G, and then 5G. So let's now explore how this mobile network architecture has evolved, which is really transforming from hardware-centric system to intelligent cloud-native network. What I mean by this is, till 4G, no, we were basically depending on the complete hardware system that has been deployed or that has been installed. But 5G is a cloud-native network. That means software-driven. Let's discuss about it. So to start with 2G architecture, it is mainly designed for voice communication, which we have seen recently. It introduced digital communication, which replaced 1G. Here the networks were primarily circuit switched. What I mean by circuit switched here is, you will have a dedicated path for creating each call. And the architecture depends on the key components like I have mentioned here in the slide, BSC, which we call it as a base station control. What it does, it manages the resources, radio resources. And secondly, MSC, the mobile switching center, which handles the call routing. And third one is HLR, the home location register, which stores the subscriber information. And DLR, visitor location register, which tracks the user in roaming areas. So in simple terms, we can say 2G networks are voice-centric with limited data capability. Then move with 3G architecture, where we use UMTS technology. With 3G, the focus is now on data services and mobile internet. So here it introduces high-speed mobile data for web browsing and email. And previous 2G generation is circuit switch, and here we have added packet switch network. So here this enables the efficient data transfer. So the key components, what has been here in 3G architecture is SGSN, which is called Serving GPRS Support Node, which is basically managing the data session. And secondly, GGSN, that stands for Gateway GPRS Support Node, which connects the user to the external IP network. So this made possible the video calling, multimedia messaging, and whatever the early smartphone application that has been developed. So 3G actually marked the transition from voice network to data-aware network. And then we go with 4G, LTE. It is actually what is called the evolved packet system. This has represented a major architecture revolution where completely we have moved to all IP network. So there is no circuit switching system. It is completely eliminated the circuit switching. And here this delivers very high speed using OFDM. So all of us know what is OFDM, the orthogonal frequency division multiplexing, and MIMO technology, multiple input and multiple output. So this is introduced a simplified architecture with E node B. That's what we call here in 4G E node B. It is basically a base station handling both radio as well control. And we have EPC, the evolved packet core, which consists of MME, the mobility management entity, SGW, which is serving the gateway, and PGW, which is called as packet data network gateway. So due to short of space, I have just given everything in a abbreviated form. So this enabled the voice over LTE, then HD video streaming, mobile cloud services, and early IoT deployments. And now comes 5G, the 5G architecture, which everybody is talking about, which is basically cloud native and service based. Now we arrive at 5G, where the architecture is no longer just faster, it is redesigned. Actually, it is fundamentally redesigned. So globally, it is defined by 3GPP. So this architecture introduces service-based architecture. What do you mean by service-based architecture? Here, the network functions communicate like software services. That is actually the very speciality of this service-based architecture. And they are cloud-native design. That means using virtualization and containers. So we will be able to do the network slicing, one of the specialty here in 5G. One physical network, which will be supporting multiple customized virtual networks. So there is a separation of control plan and user plan for flexibility. So this is basically designed to support EMBB, URLLC, and MMTTC simultaneously. So these are the major service categories which is going to be provided by 5G with these specialities. And so the core components, what is there in G node B? We call it as G node B in 5G and E node B in 4G. When I say G node B, this refers to next generation base station. So the core components involves AMF, SMF, UMF. So these are all called the management functions. And this enables the smart cities, autonomous transportation, and then massive IoT ecosystem. So 5G networks behave like a cloud platform than a traditional telecommunication system. So this is all about the generic view of 2G, 3G, 4G, and 5G mobile network architecture. Shall I move again? Shall I proceed? Shall I proceed?
Yes, ma'am.
Yes.
So now we talk about 5G system architecture overview. Whether my slide is visible to participants? Whether my slide is visible?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So let's now look at the architecture of 5G system and understand how the components work together to deliver the next generation connectivity. So here 5G represents a fundamental transformation in mobile network design. So unlike the previous generation, this is previous generation, no, they heavily dependent on hardware. Whereas 5G is software driven, flexible and cloud native architecture. So here there are three major components. One is UE, what we call it as user equipment. So this is actually the first equipment where smartphone, IoT sensors, autonomous vehicles, wearable devices, all are connected. So these devices, these are the examples for UE, I mean the user equipment. So these devices connect to the network to send and receive the data. So unlike earlier generation, they are designed to support multiple frequency bands, which include sub 6 gigahertz and millimeter wave. And it also uses advanced modulation and coding scheme, low power operation, especially for IoT devices. So this user equipment, say the mobile in my hand, that communicates wirelessly to 5G radio access network, and its capabilities vary depending on the use case where we are going to use. Say if it is high speed, then we have some application, or where we need less delay, then we have to choose, or where we need low power communication application, there we have to adopt. So accordingly, depending on the use case, the capacity of this 5G RAN varies. So UE is not limited to human communication. It enables machine-to-machine interaction, forming the foundation for IoT. And now the second component here is 5G radio access network. So here, this is basically providing a wireless connection between the user and the network. So manages the radio resources and then scheduling the data transmission when it has to happen, how it has to happen. That scheduling is taken care by RAN, RAN. So it basically supports high-speed communication through these advanced technologies. So for everything, the key element is the base station, G node B. So it uses the functional architecture where processing tasks are distributed between the centralized and distribution unit, which we are going to discuss in the next slide. And then comes the 5G core, the main core. The third and the most transformative component in the 5G core is what we are going to discuss. It is basically service-based and cloud-native and fully virtualized, which runs on software rather than the dedicated hardware. And it supports network slicing, which allows the physical network to serve multiple applications simultaneously. See, there is actually one physical network, and then you will have virtual networks, many virtual networks. Each virtual network will be serving for different application, but all these happen simultaneously. So it is enabling the intelligent control, automation, dynamic resource allocation. So what this 5G core does, it manages the authentication and mobility, session management, the data routing, policy control, and security. So we can say that these three components work together. These three components, I mean the user equipment, which generates the data and service request. This 5G RE again provides high-speed wireless link to carry out the data, and 5G core intelligently process routes and then manages the service using the cloud technology. So together they form a system which is capable of supporting massive IoT deployments. And then you can go for real-time industrial automation, then smart cities, all connected transportation. So like where we need a low latency application like remote surgery, and then AR, VR, there also we need this kind of service. So we will be able to make use of this technology. So the key message here is 5G is not just an evolution of telecommunication network. It is a shift towards a cloud-powered digital infrastructure where communication, computing, intelligence, all these converge together. And now we are going to talk about RAN, the radio access network. This radio access network basically acts as a bridge between the user equipment and the core network. Core network, I mean, which we have seen now, 5G. So in 5G, the base station, we call it as this GNB. So the key responsibility, what this base station does, what it does actually, it is actually receiving the signal. So the radio signal transmission and then reception. Then resource allocation, it allocates the resources and then it manages the mobility and primarily the quality of service enforcement. So if you see the functional split here in this slide, the radio unit is called the front end or a front end, which is closest to the user device. That means the user is closer to the mobile device if I am want to transmit the data. So your RF front end is going to be, the radio unit is going to be closer to the user device. So what it does mainly, it's going to handle the radio frequency transmission and reception. And the convert the digital signal to analog and start processing it. And it's going to perform the modulation, demodulation, then beamforming for directional transmission. See, rather than sending the data in a broad way, it's going to beamform so that not only the particular signal reaches the user equipment. And massive MIMO antenna processing. So n number of antennas are there, so you will have very good signal strength. So this is being operated in physical layer. And now this unit, radio unit, is going to enable us for high frequency millimeter wave communication, then precise beam steering, and converge optimization for dense environment. And now we move with a distributed unit. It's a real-time intelligence at the edge. So what this performs, it is actually doing the time-sensitive processing, main responsibility, which includes real-time scheduling of user data, and it does hybrid automatic repeat request processing, then MAC and parts of physical layer function, then resource allocation to multiple users simultaneously, and it ensures ultra low latency communication. So this we will be placing at edge data center for aggregating the data. So this is all about the distribution unit, and now we are coming to the central unit, because we have three functional units which we have seen now: RU, the radio unit, we have seen the distributed unit, and now we are moving to the central unit, which is basically a cloud level controller. It handles high level network logic and coordinate with it. So what is the main responsibility of the central unit? The mobility management, the session and connection control, and the data routing towards a 5G core network, because RAN is actually the bridge between the user equipment and the core network. So the data routing happens on the central unit of your RAN. And it also supports the network slicing. And what it matters actually, so the central unit enables the centralized intelligence and scalability. So you will have a simplified upgrades via the software updates, and it will be able to manage thousands of users and devices. So I can say in one single sentence, you can think of this central unit as a strategic brain, which manages all the policies and coordination. So how this RU DU and CU work together. First, the user sends signal, RU receives it, then it processes it immediately, I mean instantly. That means scheduling, decoding, then latency critical task, then manages the session, mobility, and forwards the data to 5G core. So this separation is connected using high-speed front-haul and mid-haul links. And now we have seen the core radio network, and finally the main part, that's a core network. Let's see. So core network is actually the most transformative part of the 5G architecture. Like unlike 5G cores, this 5G core is, unlike the 4G core, 5G core is service-based, then cloud native and fully virtualized. So this SBA, which we have discussed, no, service-based architecture, wherein the network functions are implemented as software services. So the communication happens through standardized APIs, and each network function can scale independently. So the main function, what it does actually, AMF. What is AMF? Which is access and mobility management function. Then it does SMF, session management function. Then UPF, user plane function. And AUSF, authentication service function. And finally PCF, policy control function. So all these functions called network functions, actually the modular design, no, that because of these functions, the design makes the network more agile and programmable. So 5G core runs on virtual machine, containers, and cloud platform. So this enables rapid deployment, then dynamic scaling, and also reduce the operational cost. So now we see the network slicing. It is actually the key capability that has enabled the 5G core. So I can put it in a form, a single physical network. I mean, what I'm talking about here is a network slicing, a single physical network, which can be divided into multiple virtual networks. And each virtual network will be able to perform a specific service, like one service for autonomous vehicle, and one service for healthcare, and one slice for mobile broadband. So every slice has its own job to do, so that they will be able to cover whatever the need we have. So how everything works together. So I can summarize this now, the components, all these three components. First component, UE, user equipment, which connects wirelessly to 5G RAN, radio access network. And this RAN forwards the control and data to 5G core. Then the core network manages the sessions, mobility, security, and services. So the applications and services are delivered through optimized network slices. And now let us see what is the current trend in 2026, the 5G landscape in 2026. Now see, the 5G advanced has come. It is released in the number release 18 and then release 19. They are actually the current standard. This has been evolved. And they are AI native network design. That means cloud native. The traditional hardware based core is now replaced by cloud native standalone structure. And then the network functions runs on a software container in a cloud. And this is able to, the rapid scaling, autonomous, and then continuous updates. So we will see here the 5G advanced technologies, which is now coming up. We have XR as well, metaverse support. There is virtual reality coexistence and expanded metaverse applications, and small IoT capability with the cost efficiency can be done. And then we have NTN integration, where the satellite integration can be done with 5G. And then AI and ML automation, that is intelligent network optimization, can be done. So with respect to the architecture evaluation, which we have seen, so we have this ACC, cloud native core deployment, disintegrated RAN, the service-based architecture, and finally the edge computing integration. And now let's see the use cases where this 5G advanced can be used, and also about the security. We can use this in industrial automation for mission critical operations and autonomous vehicles. I have mentioned here V2X. That means what? Vehicle to any devices or vehicle or man or a machine. V2X is possible, enabling the connected mobility as well safety. And then smart cities can be connected with the help of millions of devices. That is what we call it as a massive IoT deployment. And then immersive entertainment with XR experiences, extended reality experiences. And two main points I would like to mention here is one is called zero trust security. So people can think, what is all about this? Zero trust security. In 5G advanced, we adopt this model, the security model. It means no device or user or application is trusted by default, even inside the network. So every access request is continuously being verified. So we will be verifying this continuously and then authenticated. And the security is enforced end to end across devices, then radio access network, core, and then cloud environment. It is basically to strengthen the security. To strengthen the production further, the networks are integrating the quantum safe cryptography, which is designed to resist the future quantum computing threat, and AI driven threat detection, which can identify the anomalies and then predict the attacks and also respond in real time. So this ensures 5G networks remain secure even as cyber threats become more sophisticated. And finally, I wanted to touch upon the privacy preserving part, that is also strengthening the security aspect when it comes to the 5G advanced. Alongside security, 5G advanced emphasizes privacy preserving communication, where the data processing is increasingly performed at the edge, closer to where data has been generated. And we have sensitive information which doesn't always need to travel to centralized cloud. And we also have the advanced privacy control, which allow better protection to personal as well industrial and mission critical data. So we have just seen now the evolution of various generation 1G, 2G, 3G, 4G, 5G. And then we have seen the mobile architecture, the mobile network architecture, and the main components, the user equipment, RAN, and then the core network. And where it is going to be used, their use cases, the evolvement of this 5G advanced, the security. And now comes 6G. We are actually bridging to 6G. The steps are now still on. It has not come to implementation. The research work is now going on. Based on evaluating the 5G key parameter indicators, the research is going on in sub-terahertz spectrum, exploring JCAS, that means joint communication and sensing. And now, let us now discuss on what are the various learning resources. All of us know very well, unless otherwise we keep updated ourselves, it is really very difficult to survive in this competitive world because every day new technology is coming up. So I have listed here some of the learning resources for 5G advanced and beyond. So to deepen the understanding and stay updated in this rapidly evolving field, the learning resources, these learning resources which I have listed here are highly recommended. The one is the third generation partnership project specification, which releases 18, 19, and the upcoming 20. 20 is coming now. So these are the primary global standards which defines 5G and 5G advanced technologies, architecture, and protocols. And then comes 5G PPP or 6G IA white papers. So these are called the research and vision documents. So this will provide insights into advanced use cases trials, and then the roadmap towards 6G innovation. So if you go through these white papers, it will give a good idea about how we can go towards 6G innovation. And then there are some vendor academics and technical training. So these are actually the leading telecom vendors. They offer structured certification programs and labs. So to mention few, Ericsson Academy, Nokia training program. And then these actually they focus on real-time deployment, network optimization, and hands-on expertise. And then comes the online resources, the learning platform, Coursera, then EDX. So they are actually university-led courses. The courses are offered on 5G, then AI in telecom, and then cloud computing, cloud networking, and wireless communication. So this will lay a foundation to go towards 6G innovation. And finally, the forums, the industry forums, and the ecosystem communities. So here we have GSMA. It is actually a global telecom industry insights, reports, and events. And ORAN, Open RAN, the Radio Access Network Alliance. So this is actually an open, intelligent RAN development and technical collaboration. And these forums, industry forums, it will actually help us, like, faculty members, the teaching community or the student community. It can help us to stay aligned with the industry trends. So what's going on? We will be able to get the updation by just going through these industry forums and other communities, and the interoperability efforts and the future standards. So here, the bridge to 6G is evaluating the 5G performance key parameter indicators, then the researching sub-terahertz spectrum, and then exploring the joint communication and sensing. And tools we can use the RAGES, the TrueLens, Deep Eval, and then Lang-Smith. All these are some of the tools which we can use it for working on 5G. So we started with 5G. Then we discussed on 5G Advanced, which is evolving now in 2026. And finally, the 6G.
Ma'am, very good presentation, ma'am. I have only 2 questions, ma'am.
Yes, sir. Yes, sir.
The basic question. That is, initially you start with the first slide. It's a very informative. That is how the technology revolution start from 1G to 5G.
Exactly.
Actually, the 1G means what you mean by it start by pager, no? That is the first G generation, no? Pager.
Analog signal.
Okay.
It
So
was
that is
introduced in 1980s, where only analog communication was possible. And then over a decade, I mean, in 1990, 2G has come with not only voice, but we were able to send SMS also, sir. So it is all a decade development.
Ma'am, right now, in our country, we will land upon 5G, but the many Europe and developed countries, they go by 6G, 7G. My question is that the 7G will be directly related to the advanced communication, like that movie and other transactions, especially for the learning materials, what you are listed, especially for teaching community. We are paid for that is video conferencing, video lectures. So that will be purely focused on 6G, man, isn't it?
Sir, actually, though people say that the research is on towards 6G, but still 5G implementation is not fully done. Reason because there are some challenges. We are able to do only in the urban areas 5G. We have not touched the rural areas. We are still on in the semi-urban areas. The reason because in 4G, the physical structure was established and we were having a base station. And in 5G, it uses millimeter wave. So it will not be able to penetrate through walls. So a lot of obstacles are there. So you need to deploy the cell at a shorter distance. So that means the infrastructure cost is high in 5G. That is one of the challenge. But still we prefer to go as the technology has developed. So still 5G is not fully implemented, and the research is on 6G and now the 7th generation. No doubt it's really going to come in the future, but still not fully implemented. 5G itself is not fully implemented. Research is still on.
Okay. My last question is that is the environmental related things, man.
Okay, sir.
If we go for 3G, 4G, 5G like that, 6G, 7G, I don't know where it will be land up. Actually, what about the waves and other things, man? Especially for race, it will be, somebody said that it will be very harmful to the human, even some environmentalists, they listed the new disease will be coming, especially for cancer, that type of things, purely because of rays only, that is wave propagation. It is true, ma'am?
Sir,
Or
in my
any filtrations
opinion,
will be
no.
there?
So any technology that comes, no, we have other end also, other side. It has some environmental impact, some cost, I mean, to say some disturbance, so that we have to accept. So we cannot say simply, no, it is not so, it has to. So the government should take some proper initiative to balance both. Technology should be developed because it is all based on the 3GPP specification. Whatever they say, no, according to the specification only, it is going on. So when they define it, no, they should also give some kind of importance to the environmental factors, because the signal, no, of course it is harmful. EM waves, electromagnetic waves, which we cannot define. But at the same time, it is not in individual hand, but the people who implement it, no, in the geographical domain, they have to focus this also. It has to be taken into account.
Thank you, ma'am. Thank you for nice presentation, and also your answer also, it's very easy to understand, even the other faculty. Thank you, ma'am. Thank you.
Okay, thank you.
Good evening, ma'am.
Sir, good evening, sir.
A small doubt, ma'am. Which
sir.
book or resources can we refer to get the clear idea about 1G to 5G, ma'am?
Sir, actually, there are n number of books available. Truly speaking, I don't want to specifically mention one particular author. Lot of resources are available. In that way, we don't need to run pillar to post. Earlier, those days when we were all studying, just to get a material, we have to run to library. But now it is not so. Just in a click of a button, every material is available. So I don't wish to mention only any one particular author, because now lot of learning resources have come. More than a book, I would say, you can just get connected with people who are there in the industry, who are giving the latest information. Truly speaking, even my learning enhanced only by looking at people's post on the industry forum. So that is actually giving the latest updates. Of course, to learn the basic concept from 1G to 5G, which is readily available in every other book, rather than simply going with the books written by some authors, I would suggest you to follow up with industry forums that will give you the updated information, sir.
Okay, ma'am. Thank you.
Okay, sir. Okay, sir. Sir, anything else to?
Bala, if there is no question, you can.
Yes, sir. Yes, sir. That's what I was also about. If there is no questions, we can conclude it, ma'am. So it was any questions there?
Sir, sir,
Yes,
is
sir.
it
Please go
audible?
ahead. Yes,
Ma'am,
sir. Yes, sir. Please go
this
ahead.
is Prasad, ma'am. Hello?
Yes, sir. It's audible. Please go ahead your question, sir. With your question.
Yes, sir. Ma'am, you have spoken or you have narrated how the generation have been molded and it has been working with that of GSM. The current research also focuses towards that of CDMA.
Okay.
How far it will reach or how far it will overcome with that of this GSM module?
GSM is actually 2G. That has already been replaced. Now people are no longer using, because their architecture is something very different. We had mobile station, base station, subsystem, then network switching. The one disadvantage with 5G, no, though it is not disadvantage. One challenge here in 5G is we will not be able to adopt the same device which has been used for 4G. Whenever we go with 5G architecture, no, the device should support 5G. So that is actually one of the challenge here when you are really adapting 5G. What your question is, GSM, it was long time before circuit switch data, which we are not at all using it now. We have totally transformed to all IP pack, that means packet switching. That is that GPRS edge. It was long time before developed, and now we are in the new world, 5G new. So that has not been used now. GSM has come, then GPRS has come, then edge has come, 3G, 4G, 5G. It has completely evolved. So though it has given a foundation for modern mobile communication, but largely it is now replaced by the newer technology. So, but it has played a critical role or an important role in the digital connectivity. But still they are operated in some region for IoT applications. But now currently not here.
Ma'am, the concern is instead of using this mobile portability towards antennas,
Okay.
whether it is moving towards that of satellite communication, wherever the
That's
initial
what
movement
actually,
was taken
yes,
by.
exactly. Thank you for your question. I was mentioning this, no, in 5G advanced, they are now trying to connect with satellites. I was mentioning this point here in my slide also, that they are just trying to connect with satellite data, and the work is still on. The work is still on.
Madam, I am Dr. Bhaskaran, Joint Director from Industries Department, Government of Tamil
Yes,
Nadu.
sir. Yes, sir.
Madam, I am using BSNL. It is showing only 3G. But I add one more Geo, it is 5G like that. I don't know when
Okay.
BSNL will go for 5G. What is the problem? I am really worried that I'm having two number. So I
Okay.
find it BSNL, they said if you have Geo, my data will get suppressed like that. So I'm facing lot of problem. It is going to voicemail like that.
Okay.
What is your opinion, madam? Shall I cancel BSNL and go to Geo?
Oh, sir, I should not tell that you have to cancel BSNL and go to Jio. Let's now try
Or
to adopt
shall
the
I have
newer
to
tech.
wait for BSNL to upgrade 5G? Your opinion, madam?
So we
What,
don't
madam?
know when they, sir, we don't know when they will upgrade.
No,
We
no,
don't know when the service provider is going to upgrade.
no,
So
no.
let us upgrade ourselves.
What they are telling, even Geo is not 5G. Simply they are showing 5G like that. That's
Okay,
what my
okay.
worried.
Sir, actually, it's an interesting question. We will not be knowing when the service provider are
Madam,
going
what
to
is your
upgrade.
idea in that, madam? Whether main problem is oh, no, whether I have to cancel BSNL, go to Geo, or what is your opinion, madam? What is you are having?
Sir, my personal call on this is, when technology is getting developed, let us update ourselves also. So we will go to the newer technology. So whichever is giving you the best service, we have to adapt to it.
I am asking your suggestion, madam, whether I have to go for BSNL or Geo. Only one I have to keep
That's
it.
what, sir, I have given you the answer in an indirect way. I should
Okay.
not mention about the service provider, no. So instead, I have told you, whichever is giving the best performance to us, then the user has to adapt to it, sir.
What you are having, madam? You
The
are
updated one.
what,
Updated
madam?
one. Updated one, sir, always.
Geo.
Updated.
Okay.
Updated one.
Okay, madam. Thank you, madam.
Oh, very
Okay.
nice, nice.
Bala, you can conclude, Bala.
Yes, sir. Yes, sir. Thank you so much for the interesting session, ma'am. So it was really an eye opener for the technology base that has been connected, because industrial revolution is going around us, and you could see that industrial revolution 4.0 has come into play, and this industrial 5.0 would leverage more such technologies to connect with the communication systems. So we have all the industries to be upgraded with a communication system where this IoT and other things might be consuming more data, and we would have high definition to be upgraded to another 4K to 8K. So all such informations are collaterally presented in a very great manner, and as our chairman told, it's something like even the other department who are laymen could understand it. It was a good thought process, and it was a good presentation as well. So thank you so much, ma'am. And IE also gets its pride with the 100 years organization as have a lot of industrialists been presenting their own ideas. We could also see that you have been upgraded yourself as a registrar. Congratulations, ma'am, for your new
Okay,
position.
sir.
And I thank each and everyone who are good enough to listen and as well as interact with such a wonderful lectures. And we expect more such lectures come with the evening sessions, or we could also be the part of the program we are about to join by this Friday, ma'am. So there is a technological 2 day seminar which is going to happen with Sathyabama in association with the Institution of Engineers is going to present in collaboration with Sathyabama. So that's the good news, that we would connect more professional such things, and we also, this communication might be bringing more knowledge base to all the engineers. Thank you so much, the participants, the committee members, the council members, and all the professors and lecturers who have joined, and the students, participants who are present there. So thank you so much, ma'am. Thank you, thank you, thank you.
Thank you, sir. I also express my gratitude to IEI for providing me this opportunity to be associated with your esteemed professional body. Thank you once again, sir, and thank you, participants.
Thank you, ma'am. Thank you very much.
Thank you, ma'am. Thank you. Ready, ma'am? So you can just close again. And
Yes.
we can also share the YouTube link to ma'am so that she can circulate to the remaining people. Thank you. Thank you.
Thank
Thank
you,
you,
sir.
Radhika.
Thank you, sir. Shall I leave, sir?